Hey everyone, welcome back to our channel. Today we're diving into some Java code that computes Fibonacci numbers modulo m. Let's break it down step by step. Now, this is where the magic happens. We've got a method named genFibNum. It takes in 5 parameters, a, b, e, n, and m. These parameters help us compute the nth Fibonacci number modulo m. We start with a quick check. If n is less than or equal to 2, we return 1 modulo m. This takes care of the base cases for the Fibonacci sequence. Here we're setting up a 2-dimensional list to represent a matrix. This matrix will hold the values needed for matrix exponentiation, a technique crucial for computing Fibonacci numbers efficiently. These lines fill up our matrix with initial values required for the Fibonacci sequence and identity matrix elements necessary for matrix exponentiation. We're also setting up another matrix called res, which will hold the result of our matrix exponentiation operations. Similarly, we initialize res with the identity matrix, which serves as the starting point for our matrix exponentiation. Here, we subtract 2 from n. This adjustment is necessary because we manually compute the first 2 Fibonacci numbers, and then we'll calculate the rest using matrix exponentiation. Now, we enter a while loop that continues until n becomes 0. This loop is where the matrix exponentiation magic really happens. Within the loop, we check if n is odd. If it is, we multiply our result matrix res by our initial matrix mat. This is a key step in the matrix exponentiation process. Next, we multiply mat by itself. This operation is crucial for advancing the matrix exponentiation to the next power of 2. After each iteration, we have in using a bitwise right shift. This effectively divides n by 2, helping us reach our goal of computing the Fibonacci number efficiently. Finally, we calculate the result for the nth Fibonacci number modulo m. We access specific elements of the res matrix and perform necessary calculations to derive the result. Additionally, we have a helper method called multiply. This method performs matrix multiplication of 2 matrices A and B modulo m. We start by getting the size of the matrices and initializing a new matrix to hold the result of the multiplication. We then iterate over the rows of the resulting matrix and initialize a new list to store elements of each row. Within each row, we iterate over the columns of the resulting matrix. We initialize a variable sum to accumulate the sum of products of corresponding elements from rows and columns of matrices A and B. We perform the actual multiplication of corresponding elements from rows and columns of matrices A and B. The product is added to sum and then taken modulo m. The calculated sum is added to the current row. Once all elements of the row are calculated, we add the row to the resulting matrix. Finally, we return the resulting matrix after completing the multiplication. And that's a wrap. We've covered how this Java code efficiently computes Fibonacci numbers modulo m using matrix exponentiation. I hope you found this breakdown helpful. Visit again to our channel for more coding content. See you in the next one.